Welcome to Lehigh's Big Beam 2023, where your big beam can go from imagination to reality. 3 individuals work together to create a beam so big and so great that even your wildest imaginations cannot dream of. With the help of high concrete, a whole 20 feet of beam was created and stressed to be able to withstand 35 kips. The magical wonders of this big beam came about from the excellent formwork, pre-stressing strands, and shear reinforcement that was carefully selected. It was truly a marvelous conception that became a reality. Concrete was carefully poured into the formwork, vibrated, and finished to birth what we know today as our big beam. Test cylinders and beams were also formed from the same concrete and tested to attain the compressive strength and modulus of rupture. Now, our top scientists will discuss the calculation that went into the design of our big beam.
An eye-shaped cross-section was selected for its efficient material placement, and an allowable stress design approach was used to predict the required geometry based on the corresponding moment demand. Pre-stress losses were considered to determine the effective pre-stressing force on the section relative to the original jacking force. The ACI simplified approach was used to determine the flexural strength and cracking limits of the design, and stresses were checked with respect to ACI 318 allowable limits for different stages of the beam's life cycle. The maximum predicted load was found to be 35.14 kips, and the cracking load was evaluated to be 26.8 kips. ACI simplified methods were applied to determine the shear capacity and required stirrup spacing. The ultimate deflection at maximum load was predicted to be 4.277 inches. All predictions surmounted to a 49.4% error when compared to the actual test results.
Nobody. You're gonna die. You're gonna have a sweet, sweet eternal rest.
On the testing day, our extraordinary beam was set up under the 5 million pound Baldwin Universal Testing Machine at Lehigh's Fritz Lab. While the big beam was loaded at a constant rate of 200 pounds per second, the load displacement history was recorded by the LVDT sensors. The first crack formed at mid-span at a load of 18.25 kips, and after that, flexural and shear cracks were observed and failure occurred at a load of 34.82 kips with a displacement of 2.68 inches. We would like to say thank you to the Fritz lab managers Erin Moyer and Matthew Lero, and a special thanks to our professor Dr. Clay Nightel and the engineers at High Concrete Group.